Hello guys, welcome you to my new YouTube channel, Biochem Lab. So today we're going to discuss about a new title. It's atherosclerosis. So without going into much further knowledge, I will give you the things you should need and you must need. So to discuss about atherosclerosis, you first know what is this name. So we need arteriosclerosis first. So what is this arteriosclerosis thing? So sclerosis is the hardening, some kind of a thickening in somewhere, in place. So this is called arterial. So it actually refers to the thickening of arteries. So arteriosclerosis is the thickening or hardening of the arteries. So this arteriosclerosis have two types. The main type is atherosclerosis. And the second one is arteriosclerosis. So all the sclerosis things suggest some kind of thickening or hardening. So if we talk about this atherosclerosis thing, atherosclerosis means the thickening of some kind of fatty streak. So athero means a fatty streak or a fatty plaque. So a hardening due to fatty plaque is known as atherosclerosis. And arteriolo means small capillary. So arteriolosclerosis means a thickening or a hardening of a small capillary. As I said before, atherosclerosis is a hardening or thickening of an artery due to a fatty plaque. So this disease of cardiovascular system affects vessel walls, and it also leads to the narrowing of arteries or complete blockages. So, but cannot go ahead. Some strokes and even anginas can occur. Okay, so atherosclerosis has main components. There are four main components. They are endothelial dysfunction, the bit deposition, inflammatory reaction of the vessel wall, and finally, remodeling of vessel wall. So these are the four main components of atherosclerosis. And if we talk about this atherosclerosis commencement, it originally was identified at adolescence, but now it is even confirmed in utero. It is reversible in its early life, but when it is get older, it becomes hardened even with calcium, so it cannot be reversed. But healthy living, especially diet and lifestyle, could delay onset. Okay, so we talked about something called remodeling of vessel walls here. So what is this remodeling? Actually, this remodeling has two sides. It is positive and negative. So if we talk about a positive remodeling, it's actually outward enlargement. The arteries get outward enlargements. So it is not always harmful because the artery expands outwards, potentially maintaining or even increasing the lumen due to these fatty plaques. Okay, but if it is a negative thing, it is dangerous, it is harmful, as the artery shrinks inward, leading to a narrowing of the lumen and potentially exacerbating the effects of plaque buildup. Okay, then let's talk about the arterial wall. If we talk about the arterial wall, it actually has four layers. The innermost layer is the endothelial layer. And then it has the tunica intima, also known as the subendothelial layer. The medium layer is known as tunica media. It consists of vascular smooth muscle cells. And the most outward layer is the adventitium, also known as tunica externa. Okay, this endothelial layer can do main two things. They are vasodilation and vasoconstriction. So it produces some components that either can vasoconstriction or vasodilation. So the component it made does either vasoconstriction or vasodilation. Okay. So under these endothelial functions, the main component we should talk about is nitric oxide. It is actually a vasodilator that produced by endothelium. As you know, I told you about that endothelium can produce many components that either can contract the vessels or dilates the vessels. So this nitric oxide can vasodilate. Okay, let's talk about nitric oxide a bit. In the case of intact endothelium, the stimulus for vasodilation can be mechanical stimulation by increased blood flow or this potent vasodilator nitric oxide. There are also compounds such as bradykinin and histamine. They also stimulate the production of nitric oxide or prostacyclin, which are vasodilators. Okay, so let's see how mechanical stimulation by increased blood flow can do the vasodilation thing. Actually, you know that regular exercises are good for cardiovascular health, in which field it is good for. So if we do exercises regularly as a habit, it can increase our cardiac output. This increased cardiac output can increase the blood flow and the frictional. So the frictional force that the increased blood flow exerts at the endothelial surface of the vessel wall is known as shear stress. So if the blood flow is increased, this shear stress is increased. This shear stress make the endothelial cells to produce even more nitric oxide. So when the shear stress increased, endothelium tends to produce more nitric oxide. This nitric oxide can reduce the oxidative stress and increase the endothelial functions and even arterial remodeling. So it is so important in our health. So shear stress can increase the nitric oxide production. Okay, let's see how this nitric oxide thing helps us. So this nitric oxide is produced by endothelial cells. So let's see how it is produced. It is produced by L-arginine. L-arginine produces nitric oxide. So the enzyme is nitric oxide synthase. So this nitric oxide goes into the vascular smooth muscle cells. So let's see how it works there. So you know that if the calcium level of the cell increases, the cells tend to contract even more. Okay, so let's see how it works. When the calcium level is increased, it binds with calmodulin, and this calcium calmodulin complex can increase the amount of myosin light chain kinase. This myosin light chain kinase enzyme increases the phosphorylation of the myosin light chains. Myosin light chains are phosphorylated into myosin light chain phosphate through this myosin light chain kinase enzyme. And this myosin light chain phosphate combines with actin and does the vasoconstriction. If we dephosphorylate this MSC phosphate, again myosin light chains comes and it does vasodilation. So the enzyme that helps in dephosphorylation is myosin light chain phosphatase. Here. Okay, so what actually nitric oxide does? So as you see here, myosin light chain phosphatase enzyme activity is increased by cGMP. So the cGMP is produced by GTP by activated guanylyl cyclase. This is the activated enzyme. So this enzyme is activated by nitric oxide. So the inactive guanylyl cyclase is activated by nitric oxide. Okay, so here you can see guanylyl cyclase is activated by this nitric oxide. So guanylyl cyclase can stimulate this action of GTP conversion into cGMP. The cGMP thing increases the dephosphorylation, which eventually leads to the vasodilation. Okay, so here it is the mechanism. So after that, the cGMP thing converts into 5-GMP using phosphodiesterase. PDE. So as you know, this 5-GMP thing can decrease the amount of cGMP, therefore leading to a vasoconstriction, as there is no vasodilation occurring here. So this is so disadvantage in penile erection. So in order to keep this thing, penile erection, this 5-GMP should not be produced. So we have to inhibit this enzyme. So we use drugs as sildenafil, which can inhibit phosphorodiesterases. So no more 5-GMP is produced. So the GMP level is increased and leading to more vasodilation. So it keeps the penile erection well. Okay, so it's actually a more knowledgeable thing. Okay, so it's over. So let's see the development of the atherosclerosis. So, as you know, the first step is endothelial dysfunction. So how can this endothelium be damaged? Yeah, a lot of things can damage the endothelium. It includes excess lipoproteins, a lot of non-spreading diseases such as hypertension and diabetes, and smoking. These factors can actually lead to endothelial dysfunction, or we call it as endothelial damage. Actually, what is happening here? Yeah, in an endothelial dysfunction, endothelium becomes more permeable. So many atherogenic lipoproteins try to go inside the vessel wall. So it passes endothelium and travels into intima. So what are the atherogenic lipoproteins? So the LDL and LDL are more atherogenic. So they try to go to intima, the layer beneath the subendothelium layer. So it is also known as the subendothelial layer. So VLDL and LDL goes inside the intima and they tend to oxidate. So they are undergoing oxidative modification. So our body identifies this as a threat to it. So they try to damage or destroy these things, this oxidative modified LDL and VLDL. Actually, they are modified oxidatively due to the presence of nitric oxide, macrophages, or enzymes such as lipoxygenase. So after facing to these things, they tend to modify oxidatively. So after this oxidative modification, they are identified as a threat to our body. So our body tries to destroy them. So our body macrophages eat them up. And they make foam cells. Foam cells are the cells. Actually, they are macrophages which ate these VLDL or LDL, oxidized VLDL or LDL. So, then these macrophages are overloaded with lipids. They become more lipid-laden. This state is known as the foam cells. They become more lipid-laden. And they actually look like fatty streaks inside these vessel walls, like yellow color something. So, after being overloaded, these foam cells actually get ruptured. And the lipids that was inside these macrophages are released to intima, and the accumulation becomes the center of atherosclerotic plaque. So this lipid that was inside the macrophages are released to the intima, and actually they make the center of atherosclerotic plaque. Okay, so and these macrophages are ruptured, So when these macrophages are ruptured, they release a lot of oxidative free radicals. So they are also known as oxygen free radicals. These oxygen free radicals get increased inside the intima after the rupture of macrophages, and they actually decrease the ability of NO as they react with NO, and they actually inactivate NO activity. They decrease the NO activity, nitric oxide activity. Actually, it is an inactivation. So NO has no longer vasoprotective function. So the reduced NO bioactivity and enhanced oxidative stress stimulate many cytokines production. Such such as interleukins, TNF alpha, and CP1, and interferons. And also monocytes are attracted to this place. These cytokines actually induce smooth muscle cells to migrate from the media to the intima. So the smooth muscle cells migrate to the intima from media. So they actually get accumulated inside the intima. So in this intima, there are more foam cells. So they actually like lipid accumulation. And the smooth muscle cells and fibers and a lot of things. So it is abnormal actually. And these smooth muscle cells even proliferate inside the intima. So over time, there's a progressive accumulation of lipids, smooth muscle cells, and fibers inside the intima. So it actually makes a growing lesion inside the intima. And this lesion grows towards the endothelium and encroach on the lumen of the artery. So this growing lesion even encroach the lumen of the artery. Okay, so this is the production of atherosclerotic plaque. So this is the basement. Okay, and active macrophages and T lymphocytes preferentially reside at the edge of the plaque. Okay, so as this is a foreign thing to our body, so our body tries to get rid of it, so it actually accumulates many macrophages and T lymphocytes to destroy it. Okay, so even macrophages secrete enzymes to degrade extracellular matrix of the cap. So now, still, this atherosclerotic plaque is covered by the endothelial cell layer. Okay, even it is just look like a plaque, it is still covered by this endothelial cell layer. Inside the endothelial cell layer, it resides. This plaque resides. Yet it is not ruptured. Okay, so but the arteries become narrow. Okay, but sometimes, after some times, T cells activated by macrophages secrete IFN gamma and pro-inflammatory cytokines such as IL-1, IL-2, and TNF alpha. Okay, so after some time, when blood goes through these narrowed arteries, this plaque get ruptured. This is when the actual problem starts. Okay, after these plaques get ruptured, actually the inside of the vessel wall is exposed to the blood flow. It is exposed to the blood flow. So you know that inflammatory reaction actually immediately occurs, and a thrombus forms here due to this inflammatory reaction. As the vessel wall, the collagens inside the vessels are exposed to blood flow, thrombus forms inside. Actually, it is due to the platelet activation. So platelets are activated and thrombus forms quickly on the surface of a ruptured plaque. So thrombus completely occludes the arterial lumen. This gets bigger, and it completely occludes the arterial lumen. So it causes tissue necrosis. Why? Because blood can't flow through this side, and so blood is not received to the tissues, and tissue necrosis occurs. Necrosis is something, a reduced blood flow to the tissues. Okay, that's all. So the development of atherosclerosis is over. So hope you find the information you need already. So if you got the things you needed, I'm so happy. So if you think that you have got the things you needed, please comment below and subscribe my YouTube channel. Thank you.